So here the typical optimization skill is going to be used to solve the problem. Now here the first situation has been given, the constraint has been given that this container should have the capacity of 1 liter. The variables that are given are radius and the height. And first thing what you have to show, generally these kind of guiding questions are not given in higher levels, so you need to actually know how to do this without these guiding questions. But since this is the first question, we have some guiding questions. Now, the volume has been given as liter, and you can see the units are in centimeters. So first thing you need to be careful is that when you write down, volume formula is a 1 liter, which is same as 1000 centimeter cube. Now, volume of cylinder, we need to know is pi r square h. So pi r square h equals to 1000. And from here, height is 1000 over pi r square. So we have written the first step, that is to find out the height in terms of radius. Now this is going to be useful for us to get the expression only in one variable form. Now let us say next step is show that the surface area is given as 2 pi r squared plus 2000 over r. Now when you look at surface area of a cylinder is 2 pi r squared plus 2 pi r h. So 2 pi r squared plus 2 pi r h is the formula for total surface area considering it's a closed cylinder. So we have got already 2 pi r square, we can see, but the here problem is that you have height, and this expression doesn't have height. So it means that we're going to use this height expression that we got here out at this place, and get 2 pi r square plus 2 pi r times 1000 over pi r square. Now this pi and pi get cancelled, one of the r get cancelled, so you get surface area expression will be 2 pi r square plus 2000 over r. So this is the second expression that we got. Now we don't use, I'm not using technology, I'm just asking to do using calculus. Using calculus, find out the maximum surface area. So now when you have already the surface area expression, let's say, surface area expression is, I'm just writing as A is 2 pi r squared plus 2000 over r. Now what we'll do is, now we'll differentiate this expression with respect to r, radius, because my area is depending on the radius. So radius decides how much area will be for the given cylinder. So I'm going to do dA by dr because I'm differentiating with respect to r. So the derivative of this is going to be 4 pi r. And then this one, first you modify before you differentiate. So it'll be 2000 r to the power negative 1. So it'll be negative 2000 r to the power negative 2. So this is going to become 4 pi r minus 2000 over r squared. So 4 pi r minus 2000 over r. This will become, this is really important because sometimes kids make mistake in the derivative of r being 1 and the entire answer goes wrong. So this equate to 0 now. So what we get is 4 pi r cubed minus 2000 equate to 0. That gives us r cubed equals to 2000 over 4 pi, and that is nothing but 500 over pi, and that gives us r is cube root of 500 over pi. So the radius is going to be 5.41 centimeter according to this result. Now, we still don't know whether this radius is going to give the maximum surface area or minimum surface area. So what we do is we're going to find out the double derivative. So d square a by dr square we're going to do. So derivative of this will be 4 pi minus, if you do the derivative of this, r to the power negative 2 if you take here. So it'll become negative, so positive 400, positive 4000, and r to the power negative 3. So it'll be 4 pi plus 4000 over r cubed, and then you take r as this value here. So you can clearly see that this r value gives me double derivative as positive. this answer, if I plug 5.41, it'll be a positive answer. Since double derivative is positive, so dr square is positive, what we're going to conclude is that this gives us a minimum surface area as small as possible. And to get the exact value surface area, you're going to plug in the formula. So you're going to plug in the main surface area formula. So your minimum surface area will be 4 pi, 2 pi times 5.41 squared plus 2000 over 5.41. So this gives us the minimum value of the surface area.